All right, so we'll get started. The slides and everything you need for today are on the GitHub repository.
Oh, they're on the GitHub. Perfect.
Yeah, so if you look at the GitHub repository, and you can go and download everything you need for today if you want to follow along in our studio. I have some scripts there, and also the slides are there as well. So feel free to use them and share them as you like. So in the repository, you'll find a few things. So you'll find the presentation notes. You'll find a couple of scripts that we'll use today. There's also a Shiny cheat sheet. So I really like the R cheat sheets. I find them quite useful, and the Shiny one's pretty good. And then there's a data folder with a couple of spatial geopackages that we'll use today. And so I just wanted to first say thanks so much to Catherine and Katie for inviting me today. This is my first Our Ladies event, and I'm really excited to be here. So great to have so many of you here in person. It's awesome, and lots of people online as well. So great to meet everyone. So in the interest of time, I'll just jump in. So when Catherine and Katie asked me what topic I'd like to present on, I was really conflicted about what to do, but I decided to go with mapping in RShiny because it's a skill that I'm really trying to develop myself. So just a couple of years ago, I started making maps in RShiny as a way to try and share my research in a more kind of engaging and interactive way, rather than just in a static paper. So I work at the Global Wetlands Project, where I do a lot of spatial modeling at the global scale. And it can be difficult to engage with those kind of big global maps. And Shiny apps are one way that I can share that research, and people can zoom into various locations, zoom into the place where they live in the world, and engage more deeply with that research. So I found them a really useful tool for that. So our journey in maps and apps today. So we'll go through some very basics of reactive programming in R, which allows us to make interactive web apps. I'll talk about some of the pros and cons of a couple of different packages that are available to us in R for map making Shiny apps. And these pros and cons that I'll go through are really just from my own experience. So it's by no means comprehensive. And I'd be really curious to hear anyone online or anyone here in the room who's tried these packages that I'll talk about, or other packages, and what your experience has been. And finally, we'll make an interactive map, and one that we can share as a web application. So this journey is really thanks to Hadley Wickham's awesome Mastering Shiny book. So if you're at all getting serious about using Shiny and really upping your skill level, I would recommend reading this book. It's great and really accessible. So why interactive and why Shiny? So I mentioned a couple of reasons why I think it's a great skill, and it's a great way to kind of make our research more open, transparent, and engaging. So it's a great tool for that. And I think, publishing academic research papers, I feel, has not really kept up with technology. So I think we can do better than just static papers. And we have the tools available to us now, especially those of us who like R, to make our static papers into more dynamic pieces of software with apps. And so why Shiny? So Shiny is a great R package that allows enthusiasts in R, like ourselves, to make quite performative apps without any real knowledge or fluency in other programming languages like HTML, JavaScript, and CSS, which are required to make web-based applications. So we don't need to be fluent in those languages to make apps, which is great. And Shiny is used by quite a range of end users. So academics use it, and also tech companies in Silicon Valley use it. So it's quite a powerful tool. One thing to note is that Shiny web applications do need to be hosted on what's called a server. And there are a few options available to you for making your web application public. So that if you have a friend or a colleague that you want to share your web app with, you can just send them a web link, and they can use it that way. So they don't have to open it up in R. So you'll need a server to do that, to make it publicly available in that way. And so there is a link here to a Shiny app server. You can just register a free account if you want to publish your web applications that you make in RShiny. It's pretty good if your web apps aren't very big, and if you don't need to be able to allow a lot of people to be using your app at the same time. If your app starts to get quite big and you need to be able to share it with more people, you might need to go with a subscription option. And just be aware as well, there's other kind of non-R, non-Shiny servers as well out there. Okay, so app fundamentals. So the basic thing about building an interactive web app is that it needs to be reactive so that someone can engage with your web app and change inputs into the web app. And your web application will react to those inputs and display a new output based on those inputs. And so programming in an app requires a new kind of style of programming than we're used to in R, called reactive programming. And so reactive programming, as I mentioned, reactive programming allows outputs to react to inputs to our web application. And so computations are really only done when necessary. So only when some input changes to the web application will our Shiny app perform those computations and display a new output. So we're moving beyond functions to reactions. Reactive contexts are lazy and cached. Okay, so they only do the computations when they need to, when there's a new input to the system. Otherwise, they use stored or cached values. So this idea of reactive programming is different from how we normally program in R. Hadley Wickham explains this quite nicely in the Mastering Shiny book, and he provides a few ways to explain this in terms of dichotomies between functional versus reactive programming. So functional programming is command-based. So normally when we're using R, we just provide R with a function, and R will carry out that function, carry out that command, provide us the output. We can save it and use it however we like. Reactive programming is different in that in reactive programming, we're actually just providing a recipe for R to follow. So some higher set of higher level goals and some constraints for R to follow in the form of a recipe. And R will follow that recipe depending on what inputs are given to the web application. And that recipe will determine the outputs that are displayed in the web app. So you can also think of this as imperative versus declarative programming, or assertive versus passive aggressive. And so Shiny provides a really nice framework for this kind of reactive programming. The framework requires two main components: a user interface, which is how our app looks. So that's what we see on the web application. And the user interface takes both inputs and displays outputs. And the second component of that framework is the server. And the server is where we provide that recipe for our web application to follow and turn inputs into outputs. So we'll just take a look at how that works. So I'm just going to quickly switch to R, and you're welcome to follow along in RStudio if you have it open. So if you have downloaded the GitHub repository to your local computer, you can just open it up by clicking on the R project file. So that's what I'll open here. And then if you open it up using the R project file, you should then, all of the paths should link up to the data that is in the repository as well. So I'm just going to zoom in so that everyone can see that. I'm just going to open up a new R script. Put that to the side. Okay, so if you want to quickly get started on making an app in R, and you have R installed, Shiny installed in RStudio, you can just type in your R script the word Shiny app, and you'll see that it'll bring up a little snippet of code. And so you can click on that snippet, and that will insert some boilerplate Shiny code where we can start quickly coding up an app. So it's going to load the Shiny library for us, and then it gives us some of that boilerplate code for first setting up the user interface. So remember, the user interface is where we provide our app with the inputs and the outputs. So what we'll see on the web page. And we do this using a function called fluid page, and we can define the inputs and outputs within that function. We then need to set up the server. And we set up the server by creating a function that has 3 arguments. It has an input, an output, and a session. Okay, so the session we won't worry about too much. That's just so every time someone runs your app, they start their own session. But the inputs and outputs will link back to the inputs and outputs that we define in our user interface. We'll see how we do that in a second. Lastly, down at the bottom, you see that there's this function called Shiny App. So the Shiny App function basically just combines our user interface and our server into one Shiny App object that then we can run as a web app. All right, so I'll just hit save on that. And I'll just save it as an example. Once I hit save on that boilerplate Shiny code, you'll see in RStudio that you automatically get this run app button up at the top right corner. And so that's how you can run your app once you set up your user interface in your server. So that's a way to get started quickly. And just to show again the basics of programming an app in R, we'll use a simple example where we'll make a dynamic histogram app. So if we want to make a histogram in R, we can use this code here where we use the function hist to make a histogram. And here we're saying, provide me with a histogram plot of 25 numbers selected randomly from a normal distribution. So that's what this rnorm function does. And the sample size we've asked for is 25. So that's a simple histogram, but we can turn this into a dynamic histogram where we can get a different histogram depending on the sample size that we choose. So we can allow end users to kind of engage with our histogram that way. So we'll do that quickly in R just to show how that reactive programming works. Okay, so I mentioned that in the user interface, we need to define the inputs and the outputs. So our input is going to be, we want to be able to provide a way for people to select the sample size. So we'll use a function called numeric input, which will provide that little a way to select sample size in the user interface. I mentioned that the Shiny cheat sheet is quite good. So I'll just open that here to show you the kind of information it provides. And if you're looking for different types of inputs displayed in your user interface, in the Shiny cheat sheet, you can see that you can use action buttons, checkboxes, you can input dates, and we're going to use this numeric input function for our histogram. We'll also have to define the outputs. And so there's a few different output functions in our Shiny. So we're going to be displaying a histogram as an output. So we'll use this plot output function. And in our server, where we provide the recipe for this web app, we'll have to use the corresponding render function. So we'll use the render plot. So our Shiny cheat sheet is quite useful if you're not sure exactly what's available to you in terms of setting up your user interface. So we'll use numeric input. The first thing you need to do when you're defining an input or an output is to give it a unique ID. Okay, so we'll say that the unique ID for our numeric input, we'll call it N. We'll give a title for that dropdown input, which will be sample size. And we'll set the value to start at 25, which we had initially. So I find when I'm making apps in R, it's really quite an iterative process. And RShiny is quite nice because as soon as you start defining things in your user interface, you can run the app to see if it's displaying things as you want. So I'll just quickly run the app. Oh, shoot. Just 1 second. I'll just go grab this code. Save that, and then if I run it, so automatically we do see that input in our app user interface. And we can change the sample size here. But of course, we haven't defined the output yet or the recipe, so nothing really happens. So next we'll define the output in the user interface, and the output will be a output plot, I think is the function. Plot output backwards. So do a plot output. And again, any output that you define, you need a unique ID. So we'll just call this hist. Okay. But again, if we go to run this app, it won't do anything because we haven't provided that recipe yet. So we'll provide the recipe in the server, and we'll just define what that output should be. So we just gave the output a unique ID in our user interface, which was hist. So we'll define the output in our server with the same ID, output $hist. And then we're going to use that corresponding render function, which was render plot. Okay. And render plot provides our basic kind of reactive context for our RShiny app. So this is how we're starting to do some reactive programming. And so we'll just, again, make a basic histogram, random numbers from a normal distribution. But instead of giving a number here, this is where we'll provide that input that will come from the user interface. So we gave our input the unique ID of n. And so we just need to use that unique ID here in the server. So input $n. Okay. So this is how the server kind of links up the inputs and the outputs. And we'll follow a recipe. And every time there's a new input to our web app, the server will react to that input and display a new output by following the recipe. So we'll just run that app. Hopefully it works. So there's our histogram with sample size of 25. And we can change that, and we should get a new histogram every time we put a new input into our web app. Okay, so that's a little bit boring, so we'll move on. That's just a very basic example, but that's the fundamentals of making an app in RShiny, and it's very quick, so we made it in the space of maybe 5 minutes. But what about maps? That's kind of why we're here today, is how do we make interactive maps in Shiny apps? So my go-to for mapping in R these days is tmap. I really like tmap because I can make quite quickly really nice publication quality maps in tmap, but also if I just want to explore my spatial data, I can quite quickly make an interactive map with tmap as well. So it offers some flexibility. Of course, there's many other great packages for making maps in R as well, including ggplot, but tmap's my favorite these days. So we'll just make this tmap in R. So I'll get rid of this code. And if we want to make a map with tmap, we just need to load that package. Tmap provides us access to a database called world. So I'm just going to load that world data frame. If you go to your global environment, you'll see that we now have access to this spatial data called world, where we have 177 rows and 16 variables. And I can very quickly make a map of this spatial data using this function called QTM, Quick Thematic Mapper. And so all I need to do is do a quick thematic map of world, and we can see that map very quickly. If I want to make this an interactive map, all I have to do is set the mode to view. So I'll set the tmap mode to view, run that again. And now we have a nice kind of interactive map. We can zoom in, and it also allows us to get a pop-up window if we click on a polygon, and we can see what those 16 different variables are in this world spatial data frame. So I quite like tmap, and if you're in a hurry and you quite quickly just want to be able to share with a colleague a map that you've made and let them explore it interactively, you can put this into a Shiny app. So I'll just ask for that Shiny app snippet again to get my boilerplate Shiny code. And I'll just rearrange things a little bit here. So I'll move my library up. And I'm going to get rid of this tmap mode. And so tmap provides us with some specific tmap functions for RShiny to allow us to define those inputs and outputs and to render them. And so we'll just define an output here. So we'll do an output tmap, I think. Can't remember what the Oh, sorry, it just seems to be a bit slow, the slides sometimes. Sorry about that. Oh yeah, so I always say it wrong. So it's tmap output. Remember, every time you define an output, you need to give it a unique ID. So we'll call this one map. So we've defined an output. Now we need to start making that recipe in our server, and we'll define an output and give it that same ID. So output $map. And we'll use a function called render tmap to render our map. Okay. And so all we need to do is provide that quick thematic mapper function and give it the world spatial data frame. If we want to provide some colors for the different countries, we can ask it to color the different country polygons individually by giving the attribute name, which is an attribute in the world data frame that provides names for each of the countries. So if we save that, we'll see if it works. I'll hit the Run App button. Cool, so we have now in a little application our interactive tmap. And once again, you can zoom in, click on polygons, get pop-up windows. So if you don't need to make a very fancy app, this is actually a really quick way to get an interactive map running that you can then publish to your Shiny server and share with colleagues or friends or whatever. So I've used tmap to do that quite a bit in the past, but I have found it's a little bit limited if you want to customize your interactive maps with more features. So that's where you might like to go to a different package in R for making interactive maps, like the leaflet package, which we'll use in a little bit. So I've been using the leaflet package quite a bit lately, and I think it offers a lot of great functionality. There's lots of other R packages out there for making interactive maps too, though. So tmap and leaflet both use something called scalable vector graphics to render graphics on the web. And so this is fine if your apps don't have very complex spatial data, or you don't have a lot of points to render. And also if your app is not making very complex computations, SVG should be fine. But if you start to have really big spatial data sets and you need to render hundreds of thousands of points, these SVG R packages are going to be really slow. They're not going to be very performative. And so you'll probably need to look to scaling up your web app by going to a different R package that allows graphics to be rendered in something called WebGL instead of SVG. And so there's a couple of R packages that do that. There's MapDeck and RDeck. I've used MapDeck quite a bit, and I think it's great. The one trade-off is it doesn't yet allow those kind of pop-up windows. So that's where I kind of will revert back to leaflet if I don't really have a very complex or big app to use. I'll still use leaflet in the first case. But if you are getting quite a complex data set with large spatial data, you might need to go to one of these packages. And I should say MapDeck also offers some features that leaflet doesn't. So it does some really cool things with heat maps. So it's worth checking out both packages. But I would kind of always recommend starting out with an SVG package first. And then if you need to move to WebGL because you have more complex requirements, you can do that later. So I recommend starting SVG first. At least that's been my experience, what works best. And just to note as well that these WebGL packages require an API token to access base maps from something called Mapbox. So Mapbox provides base maps just like Google Maps or ArcGIS. And so if you're using MapDeck or RDeck, you need an API token to access those maps. So that's just kind of one more kind of con of those packages. A couple more tips and tricks. So if you do find that you're building a interactive map in R and it's quite slow, rather than going to WebGL straight away, the first thing you might want to try is just simplifying your vector data. So especially if you're working with a big polygon data set with lots of vertices, I've found that R Map Shaper is a really nice package to simplify those polygons a little bit, and that can really speed up a slow app. It's a really easy fix. So recommend that. If it's still slow, you can use this base R package called Profviz to profile your script and find out where the bottleneck is. So profiling just means that it will run your app and give you a report on where your app is spending the most time doing computations. So in that way, it allows you to find out where that kind of bottleneck in speed is. And so you can focus your efforts on fixing that bottleneck. Finally, you might eventually hit what's called the cliff of complexity with your web app. I've recently hit this cliff of complexity. It's quite frustrating, but also fun when you start solving it. So the cliff of complexity just means that your web app has so many inputs and outputs, and so many ways that those inputs and outputs are related to each other within the recipe that you're creating in the server, that it's almost like too much for one person to understand how it all works together. And so when you reach this cliff of complexity, there's this great book called Engineering Production Grade Shiny Apps. I encourage you to check it out. And it shows you how to do what's called modularizing your web app, basically splitting up your web app into various chunks. That just makes it a lot easier and more fun to work on. So we won't cover modules today, but just to be aware that that's something if you do kind of start building a really complex app. Great. So those were kind of all the things I wanted to say about making interactive web apps in R. And then I've just, we've got about a half hour left to do some examples in leaflet. And I know that one of you said you're already using leaflet a little bit and have encountered some frustrations. Yeah, which it can be. So yeah, we'll do that, and we'll turn our interactive leaflet map into a Shiny app. And that's it. So just before I jump into that, are there any questions about any of that information? Just have a quick look at the chat. Any questions in the chat, Catherine?
No. I had a question just looking at that server function. The render T map has like a parentheses bracket. Like,
yeah.
What is that?
That's a great question. And that's a little bit beyond my level of understanding. I'm actually not sure. I don't know if anyone else can answer that question. But just all I know is that all of the kind of rendering functions, all of the reactive functions actually. So even if you'll see in one of the scripts we use something called an observe, which allows us to, again, do some reactive programming in our server. They all have that kind of
okay, so it's
parenthesis
basics,
and then curly
reactive coding thing.
It's a great question. I actually can't be confident in saying whether that's true or not, but
I'm just wondering, like, as a beginner, like, when do I know to have it and when do I not, I guess? Yeah,
that's a good question. And
automatically, when you do render tmap and do the bracket, does it automatically add the curly bracket?
Yeah, that's a good
I
question.
don't think it did when I just tried. So I can just see that it's like a point of failure.
Totally.
I forget it.
Yeah.
No idea why it's not working.
No, I hadn't even realized that. And I thought maybe the Shiny cheat sheet would help us out, but actually I see that they don't show those curly brackets either. So that is definitely something I'm going to Google after this. It's probably in the Mastering Shiny book. Is there anyone who can answer that question? No?
I think it contains everything. So that's what's passed as the expression argument to all the render functions.
Okay, so it's kind of like a function, but it has multiple functions in it.
Yeah, you're sort of like passing all the code within the curly brackets as the expression argument to the render.
So instead of having argument, comma, argument, like
it's just one big expression.
That makes sense to me. That's a good answer. Thank you. Yeah. Cool. So I'm going to get rid of this example now. So if you just want to follow along, there's two scripts here. We're going to start with the leaflet map, and then we'll move on to the leaflet app. And I'm going to do my best to kind of practice my coding and speaking by doing it on the go. We'll see how, I'm not very good at this, so apologies in advance. So let's just start by making a leaflet map. So we need a few packages. I'm loading the simple features package, which is great for working with vector data in R. Then we'll do some data wrangling. So I'm loading dplyr, the leaflet package, and the Shiny package we'll need later on when we turn this into web app. So let's just start by making an interactive leaflet map. So we have leaflet loaded. All we need to do really is use this function called leaflet. So I can hit enter on that leaflet function. And right away, even though there's no map there, we actually have kind of like the basis for a leaflet map. We just need to tell it to put some map tiles onto that kind of base that it's given us. So we'll do that by piping to a function called add tiles. Okay, and that'll add some map tiles to our leaflet map. So just be aware that you can kind of pick different styles of base maps using that add tiles function. So we'll just use the default here. But this is a little bit boring. We don't really have anything on this map. So I'll go get some spatial data. So in your data folder, you'll find two different geopackages. So we'll load one, which basically has measurements of population size at various places across the globe. So I'll just call that pop. And I'll use the function stread, this is from the simple features package, to read in that spatial data. And so it should be in the data folder. And it's a geopackage called population geopackage. And we can see that that's loaded and that it's a point spatial data frame. So it's just points with population size. Then we'll load the reefs data. And again, we'll use the stRead function. And this is line string data that we'll plot in our map. Okay, so now we have some spatial data that we can add to our interactive map. So I'll just copy and paste this code down here. All we need to do is pipe to another function to add on. We'll start by adding on the points, and we'll use circle markers to do that. So we use the add circle markers function. We just need to tell it what the data is. And so the data we've called pop. I'm gonna, just because I know already that it's gonna plot really thick lines on all those circle markers, I'm gonna use this weight argument to reduce the width of those lines around the circle markers. So I'll set it to 0.5. It ranges from 0 to 1. And we'll just have a look at what that looks like. Okay, so those are all of our points, and you can see we can't really see anything. They're all overplotting each other. So the first thing I'm going to do is change the radius of those points. And I'll make the radius of the points proportional to the maximum population size in the population data set. So if you're curious to see what attributes we have available to us, I'll just look at the head of population size, or sorry, our population data frame. And you can see we have 3 variables. We have the name of the place, its sovereign country name, and the maximum population size. Okay, so I want to set the radius proportional to that because there's some places with very few numbers of people and some with very large. I'll just compress this on the log scale. And I'll just ask for that pop max variable. So let's see if that works. Okay, so I get an error, non-numeric argument to a mathematical function. So I just need to tell R that this variable is a number. So I'm going to say as numeric of our pop max variable. See if that works. Okay, so that works. We still can't see much. The circles are still too big. So I'm just going to quickly divide by 10,000 and see what that looks like. So that's a bit better. And so we can already start kind of engaging with this map. We can zoom in. Remember, with TMap, we could get pop-up windows really easily. Leaflet doesn't provide that straight away, so that's something we're going to have to code into our leaflet map if we want to have pop-up windows to get more information on these populated places. Okay, so we'll do that in a second. Next thing I want to do, though, is just add on that reef data. So I'm going to use the function add polygons. It will add those. It adds line strings, but we'll also do. It'll do polygons and lines. That's what I'm trying to say. Reefs, and I'm just going to change the color of those because I want to see them quite easily. So I'll just change the color to red. Oh, it doesn't like my Canadian spelling. Cool. And again, the thickness of the lines is kind of overplotting these a little bit. So I'm just going to change the weight again. I'm going to set that to 0.5. So that's a little bit better. So now we can see those reefs. So our map is getting a little bit more interesting, but we really want to be able to find out more information about those places. So we're going to add some pop-ups. So we need to create a pop-up variable with the information that we want in the pop-up windows. And that code is a little bit complicated, so I'm actually just going to go and copy and paste that from the script that we've made already. And we'll just talk through it for a second. So basically here, I'm just making a new, this will end up being just a vector, a character vector of the text that we want to display in the pop-up windows. And we do that by first using this really handy function in the simple features package called st_drop_geometry. That will quite quickly turn our spatial data frame into a normal data frame, a little bit easier to work with. Then we're going to pipe to a mutate, so we can create a new variable in our data frame called popup. Okay, and this variable is going to contain all of the information that our Shiny app needs to render some text in the pop-up window. And to do that, it requires some HTML language. So that's what you see here in green, is markup language to render that text in a web graphic in a pop-up window. So I won't spend too much time explaining that, except that you can see it's defining some of the style for that text. We can also put text into, give labels to some of the information that we're providing in terms of country and max population size. And then you can also see that here I'm calling on the 3 different attributes from our population data set. So I'm grabbing all of those individual attributes so that we can display them in the pop-up window. Okay, and then lastly, I'm just piping to a function called pull, which will pull out this new variable that we've created called popup and turn it into a character vector that then we can put in our leaflet map. So I'll just run that. And what you see is that down in your global environment, you do have this new character vector called popup with all of that information. So now if we want to add a pop-up, we just have to go, now that we've created that variable, there's an argument called pop-up in the circle markers, and we just need to give it our new character vector that we've just created. So I can hit enter on that, and let's see if it worked. We should be able to click on some of those points. And now we get a nice little pop-up window with the name of the place, the country, and the max population size. So a little bit more effort compared to TMAP. Okay, I think that's all I wanted to really show in this example. So now what we'll spend the rest of our 15 minutes doing is turning this into a Shiny app. Okay, so I'm just going to use my Shiny app snippet to get started. I'll just rearrange things a little bit. So I want to move my library. Oh, I've already got the Shiny library actually. And I'm going to start defining the user interface. We'll define the server, and then we'll wrap it all up into a Shiny object. I'm just moving around some notes I've made for myself. Okay. So when you're creating a leaflet Shiny app and you want a pop-up variable, you will have to create that pop-up variable before you start defining the user interface in the server. So I usually will do that after I load in my spatial data. I'll just reduce that. Okay, so the first thing we need to do is load the packages that we need. So all the packages that you need to run your Shiny app. We'll read in any spatial data we want to put in the Shiny app. We'll create the pop-up variable. And then we'll start defining that user interface. So remember, the user interface is where we create the inputs and the outputs. Sorry, I know I'm moving around a lot. I hope I haven't lost you on the script. So the first thing we want to do is, let's start by providing an input. So this time we'll add some reactivity to this map by allowing end users to kind of zoom to different countries in the world by selecting a country from a drop-down list. So we're going to use a function called select input to create that drop-down list. Remember, every time we define an input, we need to give it a unique ID. So I'll just call this var. And I want to, I'll call it select country. And then in the select input, because it's a drop-down list, we need to provide it with the different choices, so with the country names. So I'll just define a character vector with those names using the C function. The first option, I'll just allow the option global, so that if somebody zooms into a country from the drop-down list, they want to go back global, that option is there for them. And then I'll just provide the unique country names that are available to us in this population data set to define the rest of the list. So to do that, I just need to look at our population data set and get the country names. The country names are the sovereign country names defined in this variable. So that will give us all of the country names, but we just want the unique ones. So I'm going to wrap this in the unique function. Okay, so we can see what that looks like. I'll just copy and paste this in the console. Okay, so we've got a character vector there with all of the country names that we need. So that should be fine. And the last thing we can do with this select input is to tell it what to select first when it first starts running the app, and I'll set that to global. And so remember, the process of creating a Shiny app can be really iterative. So you can kind of check to see if you're on the right track before you get too far. So I'll actually just hit save and I'll hit the run button. I'm not yet. That's odd. It's almost like I'm not in a Shiny app context. What have I done wrong? Okay. So I'll just hit run app. So we have that input and we have the drop-down list. One thing you'll notice is that the drop-down list, the names of the countries are kind of out of order. So we can quickly solve that by just using the sort function to sort by alphabetical order. So I'll just add that on here. Save. Great. But we need to define, we've defined the inputs, but now we need to define the output. So leaflet provides us with some functions for rendering leaflet maps. So we'll see if I get it right this time. I think it should be leaflet output. Yeah, cool. Leaflet output. And remember, we just need a unique ID. So we'll make the unique ID map. Okay. So we've set up a very basic user interface that will allow some reactivity because we've allowed for some inputs into the web app. So now we just need to start making the recipe for turning those inputs into outputs. So we'll define our output object first. Remember, it needs to have that unique ID that we've defined in the user interface. So we'll call it output $map. And we'll use the render leaflet function. And now we basically just want to move our leaflet map code that we created before into this render leaflet function. And just as Catherine noted before, which I've forgotten, you need to have what allows for that expression, to hold that expression in the function. So we use the curly brackets to do that. Okay, so if we want to check and see if that's all working, we can quickly run the app and see if the inputs are talking to the outputs. So that's great. So we've got our interactive map. It still has the pop-up windows, which is great, but our drop-down list isn't working. So it doesn't really know how to turn the inputs into outputs yet. So we're going to do that by using a leaflet proxy function within an observe reactive expression. So an observe will only run when inputs to the app change. And then it'll follow the recipe to kind of update this kind of base leaflet map that we've created. So we'll do that in this observe. As I mentioned, we'll use what's called the leaflet proxy function. So the leaflet proxy is just a little bit different from the render leaflet in that, it's only going to update specific components of the leaflet map and just those components that will change based on the inputs. And right now, we just want to change this base map depending on the bounds of the country that we've selected from the drop-down list. So we'll do what I like to call an observe and fly. We're going to fly to the bounds of the country. So we'll use leaflet proxy to update this map when the inputs change. And the leaflet proxy, we need to use the same unique ID for the map output that we have up here, the output $map. So we're going to tell it to update that map object. So then we can just pipe to add on or change the layers that we want or the components that we want. So there's this nice function called fly to bounds, which will zoom into different places on our map based on a bounding box. And so in order to define the bounding box, though, we need to define that first. And so we want it to define the bounds based on our select input that we have in our user interface. And so the first, so we'll just create a variable called bounds where we can store the bounding box of those different places. And our spatial data frame is called pop. So we'll just ask for the bounding box. So this is a function in R called, in the simple features package that will give you the minimum and maximum lets and longs of your spatial data frame or a polygon that you're interested in. So we want the bounds of our global data first. So we'll ask for the bounding box of the entire population spatial data frame. So we can run that. And so that's stored for us this named vector of the bounds of our spatial data frame. You can see that in your global environment, it's this named numeric vector. So because I know from experience this is going to cause problems, one of the things we need to do is get rid of the names on that vector. So we'll use a function called unname just to get rid of those names. And so now when we look at bounds, we just no longer have those names on that vector. And we'll be able to just pull those let and longs into the fly to bounds function. So quite simply, we'll just call for the first number, the xmin, the second number. And so here we're just defining those bounds for the map to fly to. Sorry, that should be a 3. Cool. But so this is how we'll be able to zoom back out to the global map, is by using these bounds. But if we want to fly into a country, we'll have to do something else. So I'm just going to pop in a little if-else statement here. So whoops. I'll say if the input, remember that our select input, we gave that the unique ID of there. So I'll say that if our select input is there, sorry, I know we're almost going over time. I think I just need like 5 more minutes. If the input is equal to global, we're going to kind of zoom to the bounds of the entire data set. But if it's something else, if it's not global, I'm just going to copy and paste this code. And we'll set the bounds to the population data set filtered for that specific country. Okay, so it's getting a little bit complicated. So in here, I'm actually just going to wrap that population data set in the filter function from dplyr, where I'll be able to filter for the country name, or it's actually spelt a little bit weirdly. So I'm just going to ask for the head of pop. So remember, our 3 attributes are here, and the sovereign country name is listed here. So I'm just going to copy and paste that over here. So we're going to filter this population data set for the specific country that we want to zoom to. So where sovereign name equals the input to our select input box, input $sign there. So that's going to filter for a specific country for us, so that we can then zoom to it. Cool. So I think we'll see if that works. So again, we'll store the bounds of that unique country here, and we'll be able to fly to those countries with this function. And all of this is wrapped in an observe. So that means that this will only happen when inputs to the web app change. So when we select a new country, will this part of our server recipe run? I have a feeling I'm forgetting something, so I'm just going to try and run it and see if I'll get an error message, which I suspect I will. If that's working. Let's see if we can zoom in somewhere. Oh, yeah. So it's working, which is great. It's a little bit slow. We'll see. I think, oh, that's great. Is everyone who's trying it, is it working for you? You have an error? Because it's
something in here and this. It's the first time.
Are there any questions online? Oh, okay. Yeah. Okay, so I guess that's working. I'm a bit surprised because I was having issues before where I had to buffer some of the points where there was only like a single point, and the bounding box actually was the same, min and max lat and long, and it wouldn't do the zoom. So in the example script that's in the repo, you'll see that I just buffered by a distance of 1 kilometer, and it solved that problem. So if anybody's encountering that problem, let me know. But otherwise, that's basically it. So thanks so much for coming. I hope, there was something interesting for everyone in the talk. I know we went from very basic apps to something a little bit more complicated. If you'd like to chat about that cliff of complexity that I mentioned, I'd be happy to. I'm just starting to learn how to use modules and Shiny apps, which is really, it's making it, a lot easier. It was a bit of a learning curve to kind of get a handle on how those work, but it's well worth the effort if you're making complex apps. So thanks again. And thanks again, Katie and Catherine. It's really fun to be here.
Thank you so much. Can you give a round of applause? I have a question, and anyone's welcome to ask a question. What is module, the thing you just mentioned? So is that like putting it into multiple scripts? Or
basically what you could do, like one example of how you would use a module, well, actually, maybe what I'll show a really nice app that I like that uses modules. And so this app, just to give you an example of like the fantastic things that RShiny can do. Sorry, that's the code for it. I'll just show you the map first. Like this map was made using RShiny, and the code's publicly available, so you can go look at it to learn. But basically, it's a little bit more complex. So they have these various tabs at the top. So you can move to different tabs, and it just takes a second for the map to load. But yeah, you can see that each of the tabs kind of plots different things. And how you can use modules is to basically create a module for each kind of user interface and server that goes with each of the tabs. So rather than having this one long massive script, you know, where you have to define a user interface for each tab and a server for each tab, you can just break those down into various modules. And then in your in the actual script where you kind of like compile your entire app, you've just got a few lines of code that call on those modules to bring them all together.
It's kind of like sourcing a function.
Exactly, exactly. And where it comes in even more handy, which is what I'm using them for now. So I'm creating an app with lots of tab panels, but they're actually all have the same basic user interface. The only thing that changes is like the data that's underpinning them. And so in that way, I just need to write one module, and I can have, I'm creating a panel for each different forest type. And that just becomes an argument in the module. And so then it makes it easy, really easy to just, yeah, put that into my app script and just change the name of the forest type without having to write a user interface and server for each panel. I just have to say, just use that module. I want it all to look the same, but use this data instead.
Okay.
Yeah, so it definitely comes in handy.
Probably not. I'm probably not there yet, but I kind of get it. Excellent. Anyone have questions here? Ben, in the chat there said he had a suggestion for simplifying the.
Yeah.
I don't know.
Yeah. Yeah, so that's a great suggestion. Thanks, Ben. One could restrict the if-else statement to just setting the value of the bounds and just write out the leaflet plot statements once. Yeah, so that's a great idea. I think the reason I went with the if-else is because of that filtering step. And so, yeah, I'm not sure how you would deal with zooming back out to global if you don't have an if-else statement saying when you need to filter and when you don't. So yeah, maybe you have a solution for that as well. It'd be great to hear. Any other questions?
Is this one that you contributed to?
No, not at all. I was just, yeah, I've been contracted to develop a web app for an NGO, which is part of the reason why I'm trying to upskill, because it feels like a bit of pressure. So I was looking for inspiration on like, what can I do with RShiny? And I just thought this was a really beautiful example of a really like highly performative and interactive app. If we look at this, yeah, like there's just so much you can do. So in this panel, for example, if we kind of select a scenario, a sea level rise scenario, I think it's going to take a moment to run. It'll run that, and then we can actually get like a table rendered with more information based on that scenario. So it's like, yeah, there's so much you can do with these. You can also like just turn on and off different layers here. So it's quite this kind of thing though. So what you're seeing happening here is fine if you've got small data sets, small spatial data sets that aren't very complex. It's like it's quite loads things quite quickly. Because I'm often working at the global scale, I have larger data, and that's where I kind of tried to use something like MapDeck, that R package I mentioned that uses WebGL graphics to kind of keep some speed. My apps were just too slow. People didn't want to use them because they took too long to load. So MapDeck actually solved that problem for me, but then I needed pop-up windows. So there was like this feature versus speed trade-off, which was a bit of a bummer. So I've gone back to Leaflet actually for that app and just trying to make my code a little bit more efficient by doing things like Ben mentioned, which is getting rid of long if-else statements and things like that, which will really slow down your app. So yeah, it's a really great suggestion by Ben to try not to do that, because if you've got a series of if-else's that the app has to kind of run through every time you have a new input, that can end up taking a really long time. So yeah, and that's kind of my challenge in app making is I'm not a very strong programmer. I'm still learning. And so I'm often just, creating apps, and as I am putting in hacks to kind of make it do things I want. And it's really never the most efficient way to do it.
Right, there's like making it work, then there's efficiency.
Yeah.
They're the two different things.
So at the moment, I've actually started writing an app, the same app for the third time. And it's amazing, like where I started and where it is now, and how you actually can, like streamlining your code and doing things like Ben suggested has saved me a lot of, gotten me a lot of extra speed. But you do kind of need to be a pretty good programmer to be able to do that. Thanks, Kara.